Hi students, welcome to my lectures on chemical reaction engineering. So, we are going to start kinetics of different orders reactions. It is important to understand whether the reaction is 0 order, first order, second order or nth order, whatever it may be the order, because order decides the speed of the reaction. If you know how much fast the A is consuming in a reaction, so you can design a reactor. Okay, if you means according to the speed you can design what volume of the reactor is required. So it is better to know the speed of the reaction, and today we are starting with the 0 order reaction. And if you could able to understand the present and next lecture, the things will be much easier for you in the later on to understand. The agenda is to find out speed of a reaction or rate of a reaction for a 0 order systems. Let us go to the board. Kinetics of 0 order reaction. Imagine 0 order reaction has nothing to do with the how many reactants are involved, how many products are forming. It is simply any reaction. It could be A gives rise to B, or it could be A plus B gives rise to C. And as long as it is not dependent on the stoichiometric coefficients, I mean it is a kind of 0 order reaction you can talk about, you can think about. That means rate of reaction, that is rate of disappearance of A, is equal to minus dCA by dt is equal to K. It is simply, that means the speed of a reaction is nothing but K. K is the 0 order rate constant. That means you know the K, you know the speed of the reaction. If you know the speed of the reaction, you can able to design any reactor. So let us integrate, because we are following the, finding out the kinetics, that means finding out the rate constants and speed of the reaction using integral method of analysis. And few lectures back I have discussed about the differential method of analysis. Let us discuss in the subsequent lectures the integral method of analysis, that is finding out the rate constants and orders. Okay. Let us see that minus Ra is equal to minus dCA by dt is equal to K. Okay. If you take dt to the other side, dCA to the another side, opposite side, minus dCA by is equal to K into dt. Now if you can able to integrate this equation, okay, you will get a final equation. And what limits you have to integrate? That means everything is happening in a batch reactor. All the kinetics will be found in the batch reactor only. At t equal to 0, initial time, the concentration of A inside the reactor is Ca0. At after some time t, the concentration in the reactor is Ca. So between these two time limits and these two concentrations, we have to integrate this equation. Let us apply that at t equal to 0, Ca equal to Ca0, at t equal to t, Ca equal to Ca. If you find out the integration of a constant is nothing but Ca, and up to the limit Ca0 to Ca, and here the integration for the integral dt is equal to t to the limits 0 and t. Now you apply the limits. Ca minus Ca0 is equal to K times t minus 0, t minus 0 nothing but t. From this, on the, if you multiply with the minus, if you take out minus inside, that means Ca0 minus Ca is equal to K into t. This is the final equation. That means what is the equation talks about? If you rearrange this equation, Ca equal to Ca0 minus K into t. That means how my concentration in the reactor is varying. Okay, that's what concentration of A is nothing but initial concentration minus K times t. As time is increasing, the concentration of A will reduce. Okay, K is the rate constant. And what is the units of rate constant? Today I am going to give you very small method to find out what are the units of the rate constant. K is nothing but dCA by dt. What is the concentration of concentration unit? Is mole per liter. What is the time unit? It could be minute, right? What is the units of the K? Mole per liter per minute. This is the units of the K for the 0 order system. So in the same way, we are going to find out the first and second orders about the units of rate constants. Okay. Now take this equation, CA0 minus CA is equal to K times T. Objective is to find out the value of the K using experiments. Okay. If you plot from the experiment, because I have conducted some experiments, I have conducted the particular reaction in the batch reactor, I have time data and the concentration data. That means at 0 time, that means I have started with the initial concentration CA0, that is 50 mole per liter, right, 50 mole per liter. That means initial concentration is equal to 50. Okay. And that is the time t equal to 0. What is my concentration? Is nothing but initial concentration, and Ca minus Ca0 is here. Similarly, after the 5 minutes, I take out some sample from the reactor. After I take out, what is the concentration of A here? 40. As you know, the concentration of A will drop 40. Then what is Ca0 minus Ca? Ca0 is 50 minus 40, which is equal to 10. Like that, at every different time, I have measured the concentrations and I have measured the difference between initial concentration minus final concentration. Why I have to measure this? Because in this equation, I have to plot y versus x. What is y? Y is nothing but Ca0 minus Ca, x is nothing but t, that is y equal to mx. Y is on x axis, x is on, y is nothing but Ca0 minus Ca is on the y axis, time is on x axis. If I plot, whatever I get, the slope is nothing but k. Okay, that is what. Okay, this is how we can able to find out whether it is a 0 order or first order or second order. It is whether this reaction I am conducting in the reactor is a 0 order or not. So if I plot the data Ca minus Ca0, this is Ca minus Ca0 minus Ca on y axis, and time in minutes is on x axis, and I have plotted the experimental values. I connect a line. If you can connect the line in Excel and see whether if the coefficient of correlation, that is R square value is close to 98 or 99% or not. If the R square value of this equation is close to 99 more than 99%, that means whatever we have assumed, the particular reaction which is happening in the reactor is a 0 order reaction. Okay, it is correct. If the data points and line are not matching, then whatever we have assumed as a 0 order, it is incorrect. We have to assume some other order and plot the final equation on the graph and see whether the points are lying on the line or not. As long as the R square value between the experimental values and the line are not sufficient, we have to redo this exercise again and again. Further data points, it seems to be that line, straight line, you can see, and it is y equal to mx is a straight line. All the points almost lie on this particular line. That means whatever the experiments I have conducted and with that of a model I have assumed is both are same. That means the model I have assumed is 0 order and experimental values are also 0 order. Now, and this is how the reaction order is found. And imagine, what is the slope of this line? If you plot y equal to mx, that means this particular line slope is nothing but m, which is nothing but the rate constant k. From the slope of this this line, you get the value of k, that is 2 mole per liter minute. Okay, this is how we can able to find out the rate constant value. And now you got the rate constant. What is my Ca? Final concentration is equal to initial concentration minus 2 times T, because k is 2. Ca is equal to Ca0 minus 2 times T. What happens if I plot this equation, y equal to, right, this is C minus m into x. Okay, it is a kind of line equation. That means if I plot y, that means concentration on the y axis, time is on the x axis, I see a line with slope minus 2, that means the slope of the line is minus 2. And what happens, this is very important point, the line starts with Ca0 here, because at 0 time the concentration of A is the maximum concentration, which is Ca0. As the time is increasing, the concentration of A will drop, okay, and the slope of the line is constant everywhere. And I will show you if the slope of the line is constant and what is the advantage we get and what are the disadvantages we get. And this is a straight line because the line equation is a straight line. That means the concentration will drop linearly. If the slope is constant everywhere on this particular line, that means the speed of the reaction is same everywhere. That means, like, assuming I have a reactor, any reactor, I mean the speed of the reaction at the beginning of the reaction, which is equal to speed at the reaction at the later stage of the reaction. That means the speed at which the reaction goes is the same. That means whether it is a 50 mole per liter concentration or 25 mole per liter concentration, the speed at which the reaction happen is the same. Let us find out the speed now, because now we have everything in place. What is the speed? Speed is nothing but dCA by dt, which is equal to K. This is the speed of my reaction. Let us plot. I know time data and concentration data. Time data and concentration data. Let us plot the speed. At 0 time, the concentration is the initial concentration is 50 mole per liter. At this concentration, what is my speed? Rate is minus dC by dt is equal to K. K is nothing but 2 mole per liter. At 40 mole per liter, that means when the A concentration is 40, what is the speed? Nothing but dCA by dt is equal to K, which is nothing but 2. When the concentration is 30, the speed is 2. 20, the speed is 2. 10, the speed is 2. That means, what is the speed? How you can? 2 means, what this 2 means? Means the speed is, if you start with 50 mole per liter, that is the initial concentration, the speed of the reaction is every minute 2 mole per liter will be reduced. That means if you at 50, when the concentration in the reactor is 50, the speed is 2 mole per liter every minute. That means every minute 2 mole per liter concentration will reduce. That means if you start the concentration at 50, after 1 minute the concentration of A is 48 mole per liter. After 4 minutes the concentration is like that everywhere. Whatever may be the concentration of A in the reactor, the speed is constant, because speed is not affected by the concentration. If you see this kind of scenarios, that is speed is not dependent on concentration, then those kind of reactions are called zero order reactions. And if you don't find, if speed is Ra minus dCA by dt is equal to Kca, that means it is not constant. If the first order reaction, what happens is, if the concentration of reactant is more, speed is more, and the concentration of reactant is less, speed is less. Here, even though the concentration is more, the speed is 2 mole per liter per minute. At 10 concentration, again the speed is 2 mole per liter per minute. This is what the zero order reactions are. When we discuss the first order, you will get even more clarity on what we are discussing about the speed, because speed decides the size of the reactor. Okay. Same. This is in terms of concentrations. The equations are in terms of concentration, and these are the equation in terms of conversion. Example, this is my final equation, Ca0 minus Ca is equal to K times T. Example this. If you want to plot in terms of conversions, I know if you divide this both equation by Ca0 divided by Ca0, I know Ca0 minus Ca by Ca0 is x, conversion of A. Conversion of A is nothing but K by Ca0 into T. So here you also see the line equation, y equal to m into x. What is y? That if you plot x on y axis, time on x axis, then you get the line, then you take out the slope. Here the slope is nothing but K by Ca0. If you know the K by Ca0, then you can find out the K is equal to slope into Ca0. That means either you can go with the concentration wise or you can go with the conversion wise. Both are the same equations, which are zero order reactions. Hope you have understood about the speed of a reaction in case of zero order systems. Okay. Let us meet with the first order reactions. Thank you very much.